Question 2 wants us to deal with integrating the exponential function. So we know already that if we differentiate the exponential function, we end up with the exponential function. That means also that if I am to integrate the exponential function with respect to x, I will get back the exponential function plus, of course, my constant of integration. The added difficulty with question 2 is that we're not always dealing with the exponential function on its own. We're sometimes dealing with the exponential of a different function of x. So if I had to differentiate then d dx e to the f of x, well, what do I get? Chain rule tells me this is going to stay the same, e to the f of x, but then I'm also going to get an f prime of x coming down. That means if I have to integrate f prime of x e to the f of x, what am I going to get? Dx, I'm just going to get back what I started with, e to the f of x plus c. And of course I can introduce a constant here, k, it's going to be k and a k, right? I can have a constant that doesn't matter because I can pull it in and out of the integration sign. So let's try an example. 2a is actually slightly different from this, but to solve 2a, all you need to do is expand out the brackets and then integrate as you normally would. 2b is perhaps more of this form. So let's take a look at 2b. In 2b we're asked to integrate 1 over the square root of x e to the negative 2 root x with respect to x. Well, a good thing to check first would be if I differentiated e to the negative 2 root x, what would I end up with? Well, good question. First of all, differentiate the whole thing with respect to the top. I'd end up with e to the negative 2 root x still. Then I would get my negative 2, that would still be there. And then this is the same thing as x to a half. So I'd get a half coming down and then x to the power of negative a half. Or that this is actually equal to 1 over root x e to the negative 2 root x. Wow, isn't that convenient? So actually, what is this? This is simply put, this is equal to, well, just what we had over here, because these two match up exactly with one another. Or do they? No, they don't quite, do they? Because I have a negative 2 here, so I needed a negative 1 here. Okay, so I'm going to introduce that negative 1. Negative 1 square root x e to the negative 2 dx. Right? Now I'm happy and I can have negative 1 inside and outside the brackets. That's fine because I can move it in, cancels out, it's all good. So what does that end up with? Now I've got exactly what I want, just with a negative out the front. So the negative stays out the front, and I get e to the negative 2 root x plus my constant of integration.